Yes, good morning to all. Yes, good afternoon. Sorry, good afternoon. Yes, good afternoon. Dakshay Anul Bhavishya. And good. Now we are going to start the remaining portion of term 1 exam. So next question is I think we were doing yes, initially this give an example of octet rule we have done. Now we have to start what format, all these things we have done. Now we were coming, what is the shape of this we have done, carbon dioxide, only this we also have done, which hybridization is in sulfur hexafluoride. So we have to start from here. So hybridization in sulfur hexafluoride. Sulfur hexafluoride. If we draw the structure, we should also know the structure besides hybridization. This is octahedral geometry. If you want to ask, you can, because I have not muted anybody else. Okay. So there are how many sigma bonds? 6 sigma bonds. So you can see here sigma, sigma, sigma. Let me explain something more about the hybridization. Very important point. Hybridization point is very important. So 6 sigma bond, it means hybridization is sp3d2. Okay. Always remember, if we are having a sigma bond, this is always sigma bond, one bond, sigma bond, double bond, sigma and pi. If there is triple bond, then one sigma, two pi. And one thing always remember that pi bond does not participate in hybridization, but sigma bond always participate in the hybridization. One more thing, if we are having lone pair, this is also involved in hybridization. You can see here. So this is sigma, 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 sigma. How many sigma bonds we are having? This is, you will say 4 sigma. So hybridization will be sp3. A few things I would also like to tell you about hybridization. Now you see here, if I write down, suppose water, this is sigma, 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 sigma. How many sigma? 4 sigma. So hybridization again will be sp3. One thing always remember, that lone pair that is included in hybridization. A few students they write down LOAN. This is not house loan. This is loan. This is LONE loan. Okay. So in this way we can find out the hybridization. So here one thing is, suppose we are having, this is sp3. We are having 3 sigma, then it is sp2. If 2 sigma, this is sp. Okay. Then this is 5 sigma, then sp3d. And if suppose 6 sigma, then sp3d2. And 7 sigma, it means sp3d3. Okay. So very common examples I am writing. CH4. In sp2 you will find out this BF3, AlCl3. Ethene also sp. Carbon dioxide you know very well, sp3d. Then PCl5. This is again SF6, and there is IF7. So this is IF7. So in this way you will find out these are the hybridizations. And geometry you know well. Would like to tell you, sp3 means a tetrahedral. This is, you will say, planar or trigonal. Planar, this is linear, and this is trigonal, bipyramidal, and this is the octahedral, and this is pentagonal bipyramidal. In IF7 you will find pentagonal bipyramidal geometry. Okay. So Now we will do which has bond length more, superoxide or peroxide, and why? Which has bond length more, superoxide or peroxide? Superoxide is and peroxide. Superoxide is O2 minus 1, peroxide is O2 minus 2. Okay, so half number of electrons in bonding. O2, you just remember in O2, what happens? Half 10 minus 6. That is number of electrons in bonding minus number of electrons in anti-bonding. So bond order comes out 2. In this case, there's here 8 plus 8 means how many electrons? 16. Here 8 plus 8 plus 1, how many electrons? 17. You just see beta, answer याद करना अलग चीज है, समझ के करना that is separate issue. क्योंकि थोड़ा भी twist होकर question आता है, then you will be able to answer if you have complete understanding of the concept. So it means O2 minus 2, 1, sorry, superoxide, the bond order will be equal to what? Half, that is 10 minus. Now here one more electron has come, this one more electron that will go in anti-bonding, minus 7. So you will have, what will be, you will have bond order 1.5. Now suppose we find in peroxide. One thing always remember, peroxide is O2 minus 2 and superoxide is O2 minus 1. Sometimes we just write down superoxide and peroxide. So here bond order will be equal to half 10 minus. Now next electron again will go into, in place of 7, now you will take 8, because here 8 plus 2. So here how many electrons? 18 electrons. So it means this is one bond order. Always remember, whatever they are bond length, bond order, that is inversely proportional to bond length. It means it has lower bond order peroxide. That's why you will find, due to the lower bond order, it will have higher bond length. Okay. Beta, more thing I want to say, while solving the paper, you should be honest. As far as while doing checking, I'm not sure that you have done honestly your paper, because the complete statement, the full statement that is going to resemble of there's complete same copied. It appears as if some of the statements that have been completely copied by the whole class. It means not even a difference in the SMR. So what does it show? It shows that there is a descriptive type question and all are writing the same thing. This is not possible. And a few concepts in this paper, I am finding that most of the concepts, they are very clear to you. I don't feel so. There is something wrong at the bottom. Okay. Next is orthonitrophenol is steam volatile, but paranitrophenol is not. Orthonitrophenol. Orthonitrophenol, OH, and I am drawing this orthonitrophenol, and one is paranitrophenol. Okay. You can see this is paranitrophenol. I have drawn 2 molecules of NO2OH. You can also write down OH there also. कैसे भी लिख दीजिए, there is no problem. So there is, you will find 2 molecules are joined together. So it means there is one thing is intermolecular hydrogen bonding. This sentence is very important. This word especially, intermolecular hydrogen bonding. Here you will find that in this way. So always remember H, if it is along with fluorine, I am repeating this thing again, and so hydrogen is going to join with fluorine, oxygen, nitrogen. It means we are only hydrogen bonding. Only we will say hydrogen bonding when the hydrogen is joined by either with fluorine, oxygen, or nitrogen. So here you will find that is hydrogen bonding within the molecule. That's why this hydrogen bonding is intramolecular hydrogen bonding. So due to the intramolecular hydrogen bonding, you will find this is not this has very low boiling point, or you can say this is steam volatile. But if suppose we want to boil this, you must have to break this intramolecular hydrogen bonding. Again, I am telling you this word is very important, intermolecular hydrogen bonding. One more thing I would like to tell you, never write down H2 bonding. Either you write down H bonding, or in words you write down complete hydrogen bonding. Okay. So you must have to break this bonding. That's why you require extra heat to vaporize this. So that's why its boiling point will be higher, or it is not steam volatile. So this is orthonitrophenol is steam volatile, but paranitrophenol is not steam volatile. Okay. Next is why it is not possible to cool a gas to 0 Kelvin. Not possible to cool a gas at 0 Kelvin, because you know very well, because otherwise the volume becomes almost, okay, because if we take that at 0 Kelvin, you have drawn the graph. So volume is here, 0 volume, and that is at 273. You can say that is, you can say this is 0 Kelvin or minus 273 degrees Celsius. We should write like this. So Kelvin will be minus 273 degrees Celsius plus 273. So it comes out 0 Kelvin. This is known as absolute zero. Absolute zero. So at this temperature, all the gases, they get condensed, and gas then converts into liquid. So we are not studying the property of gas, we are studying the property of the liquid. Okay. You want to ask something? अरे स्नेहा, रिजल्ट की चिंता मत करो, वेरी सून वी विल टेल यू. अभी स्कूल के एग्जाम्स चल रहे हैं. ओके, and result will come with the whole exam result of the whole school. Okay. Don't worry. So this is 0 Kelvin. What type of graph would we get when PV is plotted against P at constant temperature? This you know very well. PV pressure. So whatever may be the pressure, PV remains constant. So that's why you will find that this is parallel to the, this is, you can say, x-axis. If x-axis, at x-axis we have taken pressure, and y-axis we have taken PV, pressure, volume, work. Okay. Next is the heat of evaporation water, ethyl carbon disulfide, given arranged in the decreasing order of the intermolecular forces. Decreasing order of the intermolecular forces. Now you see here. Always remember, if the heat of evaporation of the water is high, it means forces are maximum. As the intermolecular forces increase, intermolecular forces, they are proportional to what? That is enthalpy of vaporization. I will write down enthalpy of vaporization. So it means, if suppose the compound which is having highest enthalpy of vaporization is water and lowest is carbon disulfide. So that's why we will write down water's enthalpy of evaporation highest. That's why highest maximum number of intermolecular forces, the strongest intermolecular forces. Then after water we are having alcohol, and after alcohol we are having carbon disulfide, CS2. One thing I would also like to tell you, CS2 is our non-polar compound. Non-polar compound means dipole moment is equal to 0. So very weak forces. In water, you know, hydrogen bonding. In alcohol also hydrogen bonding, but weaker in comparison to water. This is a comparative term. If I take glycerin, glycerin also has hydrogen bonding but stronger than water. So you will say this is a comparative term. If we take water and alcohol, both are having hydrogen bonding, but the difference in boiling point is because water has higher boiling point, because it has a stronger hydrogen bonding, or you can say extensive hydrogen bonding, or more hydrogen bonding in comparison to alcohol. Okay. Next, what is the sign of entropy if HCl is added to silver nitrate? If HCl is added to silver nitrate, क्वेश्चन बहुत बच्चों ने गलत किया है. AgCl if HCl is added to silver nitrate, note this, HCl is added to silver nitrate. Now you say this is aqueous, this is also aqueous. Whenever you are adding this, we will have white precipitate of AgCl. Okay, we are having white precipitate of AgCl. It means what will happen? Precipitate, due to the formation of precipitate, what will happen to the entropy? What will happen to the entropy? because entropy of the solid is, that is, you will say minimum, then liquid, and then gas. Now you see here, whenever we are having this solution, molecules are free to move. Okay, it means they are in the liquid, but now they have converted into solid, and you know, if this is solid, it means entropy will decrease, or we can say randomness will decrease. So due to the decrease in entropy, what we will find, so due to the solidification, we will say that entropy will decrease. Okay, next is, why is an exothermic reaction always thermodynamically spontaneous reaction? Exothermic reaction is always thermodynamic spontaneous reaction. Always remember one thing, that is, suppose we are having a thermodynamic spontaneous reaction, then delta H will be negative. So the question is that why is it so? So always remember, very correct answer was not given by you, but I have done it correctly, thinking that this concept is almost explains the reason. So reactants, when they are converting into the products, so in every spontaneous reaction, we will find that energy of the product, that is less than energy of the reactants. In the nature, you find that every system would like to go towards lower energy. Okay, everyone. If you become angry, your energy becomes higher, but you feel very excited and you feel very restlessness. But whenever you are just calm and quiet, then you are at the lower energy level, and you feel very yourself very stable. So the same way, when products, they are having lesser energy than the reactants, then nature, what nature does, nature always takes reactants into product. It means this is a spontaneous process, and spontaneous process means energy of the product that is lesser than reactant, and this is only possible when the process is exothermic. Okay. Now next question is, what is the value of change in Gibbs energy at melting point of ice? So what happens, melting point of ice means, what happens is, suppose no temperature was not given. Temperature was, in this case, temperature was not given. So that's why we will take, now I will tell you, this will be, this is Gibbs energy, that will be at melting point, it means it will be negative. Always remember that Gibbs energy, delta G, is negative when the process is spontaneous. Okay, and delta G is equal to 0 when, it means when that process is at equilibrium. I think most of the students, they misunderstood this question. The reason was that they were thinking that delta G is equal to 0. So that is only when we are having 0 Kelvin. Okay, if melting point of ice 0 Kelvin, this is positive. Let me see the question. If delta G is positive, then reaction will go in the backward direction, or the process will be non-spontaneous. Let me read first the question, complete question. So it will be, I think it was asked at melting point of ice, or 0 Kelvin. 0 Kelvin, at what happens, at this stage, the system is at the equilibrium. If we write down temperature 273 Kelvin, 273 Kelvin. So water and ice, there is equilibrium between these two. And if suppose we say that higher than this, then what will happen? It will go towards water. If we say lower than this, 273 Kelvin, we will say that it will remain in the ice. So as 273 Kelvin is given, so there is a transition state. And at that transition state, what happens? The system is at the equilibrium. And when the system is at equilibrium, then delta G will be equal to what? Delta G will be equal to 0. Okay. Next is, when calcium carbonate is heated and equilibrium is obtained, in which direction reaction will shift in when the pressure is increased? The question be better, most of the students, they have done it wrongly. The wrong answer is, you have given the wrong answer. Just one question before it. If standard free energy change for a reaction is found to be 0, what is its equilibrium constant? Standard free energy of the reaction is found to be 0. Equilibrium constant, you know, delta G naught is equal to minus 2.303 RT log K. Yes. What do you want? School bill not sure अनुज, अभी मुझे नहीं मालूम है कुछ भी. Log K. Okay. So if delta G is equal to 0, then what will happen? Minus 2.303 RT log K is equal to 0. Or you will write down log K is equal to 0. So K will be equal to what? K will be equal to 10 raised to power 0. That is equal to 1. Because if the power of is 0 of any value, it means that will be equal to 1. So K will be equilibrium constant will be equal to 1. Okay. Next is, next question is, when calcium carbonate is heated and equilibrium is obtained, in which direction reaction will shift if pressure is increased? If we write down calcium carbonate solid and there is equilibrium CaO plus CO2, this is gas, this is again solid. Now what will happen? If here this is 1 mole of gas at the product side, so if we increase the pressure, what will happen? Concentration will increase and reaction will go towards lower pressure side. Lower pressure side means it will go in the backward direction because there is no gas there. Okay. So in this case, the reaction will shift in the backward direction. Okay. So you are just supposed to write down backward direction, nothing else. But you have written a complete paragraph and without giving the proper reason of it. So when calcium carbonate is heated, you are just supposed to write down that equilibrium will shift in the backward direction if pressure is increased. Next is, if for an equilibrium reaction is 1.6 and equilibrium constant is 3.5, equilibrium constant, first I will write down K equilibrium constant, that is 3.5, and this is reaction quotient, that is 1.6. In which direction will it go? Always remember, I have told you that if K equilibrium, that is greater than Q, then reaction will go in the forward. If K equilibrium is less than Q, reaction will go in the backward. If K equilibrium is equal to Q, then it means the reaction is at equilibrium. Okay. Here you will find that because your Q, that is less than K equilibrium, so that's why reaction will have a high tendency to go in the forward direction. Okay. This question also came this year into your IIT mains. Next, what will be the pH of an aqueous solution of NaOH of concentration of 0.01 molar? 0.01 molar aqueous solution of NaOH. Okay. So NaOH means आपका you are having Na plus OH minus 9. Okay. So if this is 10 raised to power minus 2, so OH minus will be always 10 raised to minus 2. So POH will be equal to that is will be equal to H plus concentration into, or you will write down just pH plus POH. So your POH, that will be equal to what? That will be equal to minus log of OH minus concentration, or minus log of 10 raised to power minus 2. So that will be, POH will be 2. If POH is equal to 2, then pH will be equal to what? 14 minus 2, that is equal to 12. Okay. Because you know pH plus POH, that is equal to what? 14. So pH will be equal to 14 minus 2, that is equal to 12. This we have done very clearly in this chapter. Next is, if equilibrium constant for a reaction is 5, what will be the new equilibrium constant for the reaction if the reaction is reversed? Reversed or multiplied by If a constant is 5, then what will be the new equilibrium constant? Let me see the question. If equilibrium, what will be the value of the new equilibrium constant if the reaction multiplied by a factor of 2? So always remember, suppose a reaction is A plus B, that is in equilibrium. So K equilibrium is equal to what? 5. If this reaction is multiplied by 2, it means new equilibrium constant that will be equal to 5 square. It will be equal to 25. So always remember, if a reaction is any factor, suppose it is multiplied by A plus B gives C, this is multiplied by any factor, suppose N. So we will write down new equilibrium constant will be equal to old equilibrium constant raised to power N. Okay. And the same way if the reaction is reversed, suppose I reverse this reaction, C gives A plus B, it means the new equilibrium constant will be equal to 1 by inverse of the old equilibrium constant. Okay. So this learn these things. They are very, very important things. Next is the enthalpy of combustion of methane, graphite, and dihydrogens are these. This is what will be the enthalpy of formation of. This is enthalpy of formation of methane. Yes, enthalpy of formation of methane. So you have to prepare the reactions. Reactions will be like this. If suppose we write down, this is combustion of methane. First, write a formation of methane. Methane means you will write down methane here. Gas, what do you want? Carbon solid plus 2H2 gas. Okay. And one thing, a combustion of methane. CH4 plus O2 gas, CO2 plus 2H2. Okay. So here I will write down 2. That is given minus 890.3 kilojoules per mole. And then after that, combustion of graphite, carbon solid plus O2 gas, CO2, it is given minus 393.5. And one more H2 plus half O2 gas, H2O, this is gives minus 285.8. Okay. So what you will do? You want methane right hand side. What will you do? You will reverse this reaction. Carbon dioxide plus 2H2O. You will get CH4 plus 2O2. This question I also have told you in my lecture. So it will be plus 890.3. Here we are having C. This will remain as such. CO2 the minus 393.5. Hydrogen multiply by 2, 2H2 plus O2 gives 2H2O, that will be equal to what? If we multiply by a factor of 2, so minus 285.8 into 2. So whenever you will find most of the terms left and right, they will get deducted. We are only concerned with CH4, carbon and 2H2. Otherwise, 1O2 this, 1O2 this, and there 2O2 this will get cancelled. Carbon dioxide will get cancelled. Now you sum up them. That will be the result. It will come out minus 74.8 kilojoules per mole. So if suppose you have written plus, in that case, I also have not given the marks. Okay. So this is all about this this is term 1 exam. So now I have discussed the whole paper. You do it, and if suppose you have any problem, you can ask. Okay. So now from day after, most probably day after tomorrow, not sure. I am going to start the new chapter, that is I will start organic chemistry. Okay. I will start organic chemistry, that is from the first chapter, basics of organic chemistry. These chapters are very, very important, basics of organic chemistry and hydrocarbons. So you do that, you must attend the class. I will make the things very clear to you. You have to sit before me. So this is very important again, otherwise I am not taking it again. So please you do them. You sit there, not as a formality, but just to learn the things, because nomenclature and everything, because these are the basis of organic chemistry. If you will not understand the chapters of organic chemistry of class 11, it will become very difficult to for you to continue organic chemistry or make a good understanding of organic chemistry in class 12. So better you sit before me, you can ask the things, I will unmute you, and we will do the nomenclature, everything, the things where I would like to try. I would try my best to make the things clear. Okay. Do you want to ask something? If you want to ask something, you can speak. Do you want to ask something? Okay. बेसिक्स ऑफ ऑर्गेनिक केमिस्ट्री, स्नेहा। बेसिक्स ऑफ ऑर्गेनिक केमिस्ट्री, स्नेहा आप बोल भी सकते हो बेटा, आपको अनम्यूट किया हुआ है मैंने, क्योंकि कुछ बच्चे बहुत अच्छे से पार्टिसिपेट करते हैं, मैंने अनम्यूट किया हुआ है उन बच्चों को सभी को किया हुआ है, बिकॉज यू पीपल आर बिहेविंग इन अ वेरी डिसिप्लिन्ड वे। ओके, so